Before that, let's see what is free vibrations. If the body oscillates with its own frequency, such a frequency is called as natural frequency, and such vibrations or oscillations are called as free vibrations. अगर कोई पर्सन स्विंग कर रहा है, पर्सन स्विंगिंग इन द स्विंग, ये फ्री वाइब्रेशंस या फ्री ऑसिलेशंस का एग्जांपल होगा. If the pendulum is displaced from the mean position, it will start oscillating with its own frequency. ये दोनों एग्जांपल्स फ्री वाइब्रेशंस के हैं. और प्रैक्टिकली हम फ्री वाइब्रेशन सस्टेन नहीं कर सकते. We cannot sustain practically free vibrations or free oscillations. Today here in this concept we are going to learn about the force oscillations. By pressing your feet against ground, push the swing. Then amplitude goes on increasing and oscillations can be maintained. Such oscillations are called as forced vibrations or forced oscillations. Push the swing by pressing your feet against the ground. Not only the amplitude increased, but oscillations can be maintained. Then such oscillations are called as forced oscillations. Body is going to oscillate with the frequency of external periodic force. Body is going to oscillate with the frequency by external periodic force. Now, the motion of particle is under combined action of three forces. Before going to execute forced oscillations, periodic force which varies with the time is given by Fd is equal to F0 cos omega d t. This is the frequency of driving force, and this force varies with the time with the amplitude F0. This force is applied. When this force is applied, the motion of the particle is under the combined action of restoring force, damped force, and external periodic force. Restoring force, damped force, and external periodic force. When this force is applied to a body of mass m, the body is under action of damped force, restoring force, and external periodic force. This force is applied to oscillator. Now, if this force is applied, oscillator oscillates under two frequencies, natural frequency omega and frequency of driving force omega d. Then the equation becomes, if the body is under three forces, then equation becomes Ma is equal to minus Vv minus Kx plus F0 cos omega dt. This is the equation I am writing here. When the body or oscillator is under three forces. One is damped force, other is restoring force, and this is the applied force. into Newton's second law of motion, mass into acceleration, total force. Now I can write this equation, ma plus bv plus kx is equal to f0 cos omega dt. ma plus bv plus kx is equal to f0 cos omega dt. I can write this equation as m d2x by dt square plus b into v plus kx. Instead of v, I can write dx upon dt, rate of change of displacement with respect to time, plus kx is equal to f0 cos omega dt. This is the equation of the oscillator. This is the equation of the oscillator. When the external force is applied, body is going to oscillate with the frequency of external force. When natural oscillations dies out, then body is going to oscillate with the frequency of external periodic force. Then the displacement of the oscillator, is x is equal to a cos omega dt plus phi. When the natural frequency dies out, then body is going to, or oscillator is going to oscillate with frequency of external periodic force omega d. This is the displacement of the oscillator. X is equal to a cos omega dt plus phi, where a is called as amplitude. And this amplitude is given by the formula f0 upon, in bracket, m square omega square minus omega d square plus omega d square b square raised to half. This is the formula for the amplitude of the oscillator. f0 upon m square omega square minus omega d square whole bracket square plus omega d square b square raised to half. Now we are going to check this equation, and tan phi is equal to minus v naught omega naught x naught, where v naught x naught are the velocity and displacement at t is equal to 0. This phi angle can be written as tan phi is equal to minus v naught upon omega naught x naught, where v naught and x naught are called as velocity and displacement at time t is equal to 0, and amplitude is given by f0 divided by m square in bracket omega square minus omega d square whole bracket square plus omega d square b square raised to half. Let's examine. हमें एग्जामाइन करना है. ये एम्पलीट्यूड दिया गया है f0 अपॉन m स्क्वायर इन ब्रैकेट ओमेगा स्क्वायर माइनस ओमेगा d स्क्वायर होल ब्रैकेट स्क्वायर प्लस ओमेगा d स्क्वायर b स्क्वायर. Omega is the natural frequency, omega d is the frequency of driving force. और ये damping constant v naught और x naught को हम velocity और displacement कहते हैं at t is equal to 0. Today let's stop here.